This is the first in a series of videos that delve more deeply into some probability problems. So the first thing about probability, let's think about the difference between and or. So in probability, we can have two events, A and B, and we can say, what's the probability of A or B happening? But we could also say, what's the probability of A and B happening? And the key about A or B, this is true if A is true or B is true or if both things are true. So for example, let's say you have a deck of cards. And I say, what is the probability of having a face card or a heart? Well, that's true for all face cards. It's true for all hearts. And it's also true for all face cards that are hearts. And the easiest way to do this, to look at this, is to do what's called a Venn diagram. You don't always use a Venn diagram, but it's often very useful. So the idea of the Venn diagram is the entire population is going to be a big box. So this would be all cards. So this would represent 52 cards. And then you'd have two circles that may overlap. And let's call this face cards and call this hearts. And this circle here would represent all the different face cards. And the total face cards, the face cards are jacks, queens, and kings. So that's going to be 12 cards. And the hearts, turns out there's 13 of each suit, so there's 13 hearts. Well, the key here is, if you look at this part right here, this part right here is in the circle face cards, but not in the circle hearts. So this is face cards, but not hearts. So if you think about how many face cards are not hearts, there's the jack, queen, and king of diamonds, spades, and clubs, so that's 9. So there's 9 in here. And there's 3 here. Right? The 3 here are the jack of hearts, the queen of hearts, and the king of hearts. And here would be all the hearts which are not face cards, which would be 10. And this area here would be all cards which are not either face cards or hearts. If you wanted to count them up, how many face cards or hearts are there? There's 9 plus 3 plus 10. So there's 19, there's 22 total. So we can see that on a Venn diagram in general. If we say A or B, here's A, and here's B. A or B would be this area here. Right? That's only A, and it would also be this area, which is only B. But the key is that when in math, when we say or, we also include this area, which is both. Let's contrast that real quickly with and. If we say A and B, that's only true if both are true. So in that case, you think about what is a face card and a heart, a face card and a heart would be only those cards which are both face cards and hearts. So that would equal to the jack of hearts, the queen of hearts, and the king of hearts, because those are the only 3 cards that are both face cards and hearts. And if we look and see what that would look like in a Venn diagram, A and B, again, this would be your overall population. You'd have the set or the group A, the set or the group B, and A and B would be only that elements which are A and B both. This is only A and this is only B. This is the only part right here which are both. We use some notation that's fairly common. You use the notation A intersection B. We read that intersection. It's what we mean when we talk about and. The problem is, the reason we use intersection is this is a precise logical term versus just some English that we picked up. And if you think about A and B again, what does that look like? That's right there. If you do A or B, that's called the union. And we also use the terminology or. Using our Venn diagram again, if this is A and this is B, the OR would include everything in A, including the part that's in A and B, and everything in B. So that's union and intersection. And more introductory books often use the word and or, and then they can go to union intersection later. So that's the first in the video, and the next one we'll work on solving some problems.